Our last topic here in Unit 1 is going to deal with something called the intermediate value theorem that we're going to abbreviate IVT. So the intermediate value theorem is a theorem that tells us a little bit about a continuous function, and it allows us to make some conclusions about a continuous function under certain conditions. So the first thing I want to point out here is that one of the conditions of the intermediate value theorem is that we have a continuous function. So we're talking about this after talking about continuity, because that continuous function is a prerequisite for this intermediate value theorem to work. So what the intermediate value theorem says is that if f is a continuous function on a closed interval, so I'm going to kind of set this up in my coordinate plane here as we go. So on the closed interval, we're going from A to B, and we know it's going to be a continuous function. I'm going to draw a continuous function here in a little bit. D is a number between f of A and f of B. So f of A is, let's say the function has a point right here. So this is going to be at f of A, and f of B, I'm going to go different spot on the y coordinate. So it says that D is a number between f of A and f of B. So D is somewhere in between here. So D is what we call the intermediate value. So intermediate value theorem, we're talking about this value in between f of A and f of B. All right, so what the intermediate value theorem says is that if f is a continuous function, then at some point between A and B, so somewhere along the way here, the function is going to have the same value as D, as this intermediate value. And I'm going to just draw a horizontal line going across here. So if we think about what this means, if we start at A and it's a continuous function, we can think of continuity in kind of the informal sense, draw the function without lifting up our pencil. If I want to draw a continuous function from A to B, there's no way for me to get from A to B without lifting up my pencil, without crossing this horizontal line at D. So I could kind of get close to it and then hold off and then go up, but I'm hitting D there. I could go this way. It doesn't really matter. We're not allowed to go like that. That's not a function, doesn't pass the vertical line test, and really still it's hitting D over here. That's not relevant to what we're talking about here. But there's no way for me to draw a continuous function between this point and this point without hitting D. Now, it's important for us to understand that we don't know where it happens. We actually don't even know how many times it happens. So it says at least one time, but it could happen over and over again. We could get D 17 times. We could get D, well, doesn't matter, any finite number of times, but it has to happen at least once. So this is actually what's called an existence theorem. It doesn't tell us how to find D, and we'll talk about that in a minute, but it doesn't tell us how to find the point C, but it does tell us that this point exists somewhere between A and B so that the function is equal to the value. This should be a somewhat intuitive idea, but it does help us solve some problems in calculus that are not necessarily immediately obvious. One example, I like to use temperature as an example. If I know that the temperature this morning was 70 degrees and I know the temperature this afternoon is 85 degrees, then I know at some point between this morning when it was 70 and this afternoon when it was 85 that the temperature had to be 72 degrees. Now, I don't know that that happened at any particular time, but I know the temperature had to be there because that temperature is going to be a continuous function.